All right, so Chapter 4, Dynamics, Forces, and Newton's Laws of Motion. Now we're into the home stretch. So we're almost at the end of the chapter. So we've talked about Newton's first, second, and third law. We need a little more practice in applying this material. And so one of the ideas that we want to talk about coming up next is the net force is zero. What does that mean? So here we have a case where the astronaut pushes the space station with a force of 10 newtons. Do both the astronaut and the space station experience the same force? That seems logical that they would. Newton's third law: whenever one body exerts a force on a second body, the second body exerts an equal and opposite force back on the first. So it's the same force. It's 10 newtons. The direction is different, but it's the same 10 newton force. Do they both experience the same acceleration? Aha! No, that wouldn't be the same. That's the distinction to be made. That they're experiencing different acceleration. So for the same force, that same 10 newton force acting on our 100 kilogram astronaut, that's going to result in an acceleration of 0.1 meters per second squared for the duration of the pushing event. And for the space station, the 10 newton force divided over this 1,000 kilogram mass space station would be a lower drop by an order of magnitude, 0.01 meter per second squared. Just throwing out some numbers there for an example that no, they're different accelerations because the objects have different mass. Force equals mass times acceleration. Acceleration equals force over mass. Alright, so Newton's three laws that we will apply in a whole bunch of different ways. The first one, Newton's first law, gives us the idea, the concept of inertia that is bound up in something's mass. Newton's second law then says force equals mass times acceleration. So we're able to look at a system and figure out something. If it is accelerating, then we have some information. If it is at constant velocity or not moving, there's still information for us to get out of there, including maybe the normal force. And then we can look at the origin of the force. The force comes from one object exerting this force on a second body. It's two things interacting with each other that is the origin of forces, be that normal force or a force that is accelerating something. Alright, that's some good information. We're going to apply Newton's laws in Chapter 5.